So you guys just finished a Desmos activity introducing parabolas, and they had two different standard forms there. One of them is for parabolas facing upward and downward, and that is when the x value is squared. The other one was for parabolas facing left and right, and that's when your y term is being squared. Now I also added these pieces about p. So if p is positive and the x is squared, that means it's going up. If p is negative, that means it's going to be going down. Likewise over here, if p is positive or greater than 0, it's going to be facing to the right, and if it's negative, it's going to be facing left. So those are the ways that you can tell which direction your parabola is facing, and that's going to be helpful when you're trying to graph them. So we're going to do two examples here. This is the first one. Find the equation, the directrix, and graph a parabola with a vertex 2, 1 and focus at 2, 4. So what I'm going to do first is I'm going to go ahead and plot those on the graph. So it says vertex at 2, 1 and focus at 2, 4. Okay. So with those on the graph, what that tells you is that the distance between those 2 points, remember from the activity, is p. So I'm going to write that over here. That means that p is going to be equal to 3, which will help us write our equation in a little bit. Some other things we also need is our directrix. So remember that from the vertex to the focus and the vertex to the directrix is the same amount or same distance. So to the directrix would also be 3 units. So 1, 2, 3. That means that my directrix is going to be right here, and I'm going to represent that with a dotted line. And I'm going to go ahead and write the equation for that as well. So that equation for the directrix would be, remember, if it's a horizontal line, that's actually a y equals. So y equals -2. So I have my directrix. Great. I'm going to keep going so that I can figure out my equation and then also the graph. I'm going to go ahead and do my equation first. Okay. So if p is 3, then I know that 4p, which goes into my equation, is going to be 4 times 3. So we're going to have 12. Okay. Now, you can also see on the graph, we know that our vertex, it tells us in the beginning, our vertex is 2, 1. But you guys can also see your axis of symmetry. So it's going along here through your focus, through your vertex. So this is my axis of symmetry. If my vertex is here and my directrix is here, remember that the focus points are always going to be inside your parabolas. So what that means is that the focus is going to be inside, so that means this parabola has to be opening upward so that the focus is inside. So I'm going to make that note as well. So I know it opens up, and that's going to help us with the equation because then I know that my x has to be squared. I also know that p is positive, but I can tell that from here. So then I know that 4p has to be positive. So I'm going to go ahead and plug in this information into standard form. So this one right here. So I'm going to plug in for p, k, and h. So remember, h and k are coming from your vertex. So in this case, for p, we have 12. And our k value is 1, so y minus 1. And our h value is 2, so x minus 2 squared. So this would be our equation for this parabola. So we finished our equation. One thing I also wanted to note, when I drew in that axis of symmetry, I'm going to go ahead and write the equation for that as well. So axis of symmetry here, this is going to be an x equals equation, so that one would be x equals 2. Just so I have all that information down. The last thing that we have to do is graph. So we know that it's going to be facing upwards, but what I want us to do is at least pick 2 points to plot one on either side so that we can see kind of how wide the parabola is going. So I'm going to go ahead and do that. I'm going to do an X and Y table like we always do. Go ahead and put my vertex. And I usually try to pick a value not right next to it, but maybe a little bit further out, just so that you can kind of get an idea of the way that the parabola looks. So I'm not going to pick 1. I'm going to go ahead and actually do 0. And since that's 2 units away from my axis of symmetry, I'm also going to do 4 because that's also 2 units. The reason I'm doing that is because once I solve for one of them, if it's the same distance from the axis of symmetry, it's going to be the same thing on the other side. So that's going to help me. You guys know that it can just reflect because this is symmetric. So I'm going to plug this into my equation. I'm going to plug in 0 into my equation here. So here's my equation. I'm going to go ahead and plug in 0 for x. So I have 12 times y minus 1 equals 0 minus 2 squared. So on the right-hand side, 0 minus 2 is negative 2. Negative 2 squared is 4. I'm going to go ahead and solve for y. So divide both sides by 12. And I get y minus 1 equals 1/3. And then add 1 to both sides. So y is 1 1/3, or 1.333. So that means that that is my y value here and here. So I'm going to go ahead and plot those. So 0, 1.33, and 4. So what this is telling me is that the parabola is actually pretty wide. So I'm going to go ahead and now draw it in. And the parabola should look something like that. The very last here, I'll show this one more time in case you guys didn't get a good look. But this is what your parabola should look like. Make sure that you always have your directrix and your focus on there. Obviously your vertex as well. Okay? So the very last piece for today is going to be rewriting from general to standard. I forgot to type in the equation on your handout, so go ahead and write that equation down now. And again, just like all of the other ones that we've done, we're going to have to complete the square, but notice here we only have one square term, so we're only going to complete the square for the square term that we have. So in that case, this is y. So what I'm going to go ahead and do is move these terms over to the other side. So then I would have y squared minus 4y. I'm going to end up completing the square, I just don't know what it is yet. And then equals, if I bring that over, it's negative 2x and a plus 2. So remember, completing the square, half of b, square it. So we have negative 4 divided by 2 squared. So negative 4 divided by 2 is negative 2, squared is 4. I'm going to go ahead and add 4 to both sides. And then remember that we want to factor these. Our factor will always be b over 2. So that would be y minus 2 squared. If you need to factor that out, like using one of your methods, that's totally fine as well. Equals negative 2x plus 4, plus 6. And then just to get it to look a little bit more like our form, I'm going to transform this side and factor out a negative 2. So y minus 2 squared equals negative 2. That leaves me with x. And then remember, when you take out a negative from here, that is also going to change this sign. So it's going to be minus 3 instead of plus 3. So be careful of that one right there. Remember, if you were to distribute, it should look exactly the same. So this right here is my equation. We are going to use that to find the vertex, focus, axis of symmetry, and directrix. I'm going to have you guys try to find those right now. You need to figure out which way this parabola is opening, identify the vertex, and then see if you guys can figure out each piece. Remember, you'll also need to find P. So go ahead and do that. Once you finish, check your answers with me before you start the practice.